Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is HUSAINI bin SUHAIMI.
And I'm YUGESWARAN BALACHANDRAN.
My name is ADIB bin NAZRI.
So today we will do a podcast for our first assignment for a course GEEC 1052, and we will discuss about science and technology and the future of humanity.
So when people think about the future, they imagine flying cars or robots taking over. But the truth is, the future is already happening. Technology is changing our world every single year.
Yeah, true. And the crazy part is, most people don't even notice how big these changes are.
Yeah, think about it. Just 15 years ago, smartphones were not this powerful. Artificial intelligence was mostly in research lab. Rockets were not landing themselves. But nowadays, look what happened. Technology is already advancing.
And today, AI writes essays. Robots help in surgeries. Companies are planning missions to Mars.
So, the real question is, are we ready for what we are building? So, as our first section, I would like to talk about artificial intelligence, which is also the brain of the future. First, AI is when computers learn from data and make decisions based on patterns. It doesn't think like humans. It studies millions or billions of examples and learns from them. For example, if you give a computer billions of pictures about cats and dogs, with the collected data, it can learn to tell the difference.
So, from what you said, it's basically like training a student.
Yes. But instead of years, it can learn in hours if it has enough data and computing power. Companies like OpenAI and Google DeepMind build very advanced AI systems that can understand language, solve problems, and also even predict scientific structures. AI is already everywhere.
Yeah. A lot of people imagine AI as some futuristic robot, but the truth is it's already in our everyday life. Every time YouTube lines up videos you will probably enjoy, or Netflix suggests the next series to binge, that's AI at work. The TikTok feed that feels uncannily tailored to your taste, AI again. Even when Google Maps reroutes you around traffic, or your phone unlocks with your face, that's artificial intelligence quietly doing its job. It's not some distant concept. It's already here, shaping the little decisions and convenience we rely on daily.
Even online shopping uses AI to guess what we might want to buy.
So, basically, AI watch our pattern and behavior and it will predict what we will do next, right?
Exactly. That's its strength, prediction.
Yeah, but here's something important, which is AI is not conscious. It doesn't feel, it doesn't understand emotions like humans, because it predicts words based on probability.
So, when we ask AI to write a poem, it doesn't feel the poem that it write. Isn't it concerning?
Um, I would say no. It predicts which words usually go together in poems. But here's what's scary. Sometimes that prediction becomes so good that it looks like it's understanding.
So from the all things you said, will AI likely replace human jobs?
Okay, let's talk about something serious. Throughout history, machines have replaced physical labor. The industrial revolution replaced farm workers with machines, but AI is replacing thinking jobs, customer service, basic coding, data entry, even simple medical medicines analysis. Sorry.
Yes, I agree with you, Adik. But history also shows something interesting. Every time technology destroys some jobs, it creates new ones. The problem is tiny. People can lose jobs faster than they can learn new skills.
So when we look at how fast our technology have evolved, society must adapt in order to survive in this world.
Definitely. Example in the health sector, AI can scan thousands of medical images and detect cancer patterns faster than humans. AI is not just about cool gadgets. It's already doing some serious work in healthcare. It can analyze X-rays, predict disease risk, and even help design new medicines. That's powerful stuff. People in that field must adapt how they can benefit from this technology.
Yes, but here's the tricky part. If AI makes a mistake, who takes the blame? Is it the hospital that used it, or the program who built it, or the machine itself? These aren't small questions. They are big ethical questions. Scientists need to figure it out as AI becomes more involved in decisions that affect the people's lives.
So now let's we go deeper, maybe a bit fictional. Have you all ever heard of AGI?
Mm, yeah, I heard of it. AI is good at specific tasks, but AGI, which is also known as artificial general intelligence, will be flexible. A machine that is good at anything. It could learn physics, write music, design buildings, and invent new science also.
So, if that happens, would human lose control? I have watched many movies and series about AI taking control of humanity.
That kind of situations is mostly fiction. AI safety research exists. Scientists are working to ensure AI goals remain aligned with human values.
Today, the real issues are more related to energy consumption in AI data centers. How will it affect us?
Uh, yes, that's true. That's also a real concern. AI isn't just a clever apps. It also comes with a huge appetite for computing power. To run advanced model, you need massive data center, which means enormous energy consumption and really expensive hardware.
US data centers collectively consume about 449 million gallons of water per day, which is equal to 163.7 billion gallons per year for cooling and operations. With water usage varying by location, cooling method, and chip density, As computational demands increase, this water usage continues to grow. However, this consumption carries environmental consequences. It can strain local freshwater supplies, continue to depletion of aquifers in water-stressed regions, and overwhelm wastewater systems due to evaporation and the discharge of heated water.
And also, only the biggest company or the most powerful country can afford that kind of infrastructure. So, while AI feels like it's everywhere, the reality is that access to the most cutting edge system is concentrated in the hands of a few players and raising a question about who gets to benefit and who gets left behind.
So it means AI power may concentrate in a few hands that can increase inequality.
And I will ask something a little bit uncomfortable. Today, we have explored how technology has evolved over recent years and continue to grow at an exponential rate, shaping the way we live, work, and interact with the world around us. If AI becomes better than human at almost everything, what is the role of humans?
Hmm. Humans still have creativity, ethics, decision making, right?
But my question is, what if AI becomes better at creativity too?
So maybe the role of human is not to compete with machines, but to guide them. AI itself is not evil. It reflects the data we give. If society has bias, AI can learn that bias. If society has wisdom, AI can learn that too.
So what you're saying is AI is like a mirror of humanity. But the real question is, what kind of humanity are we showing it?
Okay, let's continue. So that we have spent a lot of time talking about AI, let's leave Earth for a bit and we will talk about space exploration.
Space exploration is one of humanity's oldest dreams. People have looked at the stars and wondered, are we alone? Can we go there?
Yes. And today, thanks to modern technology, that dream is closer than ever. Rockets can go farther, computers can guide them, and companies are even landing rockets back on Earth safely.
Yeah. Landing rocket vertically after launching into space, that was unthinkable just 50 years ago.
So let's talk about the rockets that come back. SpaceX and companies like Blue Origin figured out how to make rockets come back safely after the launch.
So why is this is so important?
Yes, because rockets are expensive. One rocket used to cost hundreds of millions of dollars. If you can reuse it, you save a ton of money and can can it launch more often.
Yeah, you can think of something like this. Instead of buying a new car every time to drive somewhere, you drive the same car again and again. So it means huge saving.
Do you know how much the US government spent on the Apollo mission? It cost about 25.8 billion. Adjusted for inflation to 2020 dollars, that equals roughly 257 billion. That crazy expensive.
But here's a question. Why go to space if we have Earth?
Well, there are a few reasons. And first is science. We like to learning about other planets and it will help us understand our own planet. Second, it resource. Asteroid have metal we can use. And the third is survival. One day, humans might need another planet if Earth become uninhabitable.
Yes, I agree with you, SYAZWAN. Plus, technology we develop for space often helps on Earth too. For example, better batteries and solar panels and also communication tech.
And today, space agencies like NASA and SpaceX are planning to send humans to Mars, conducting research to ensure that people can survive and thrive on the red planet.
Yeah, a lot of people dream about humans living there, but it's not that easy, right?
And here's the fact. Mars has a very thin atmosphere composed of about 95% of carbon dioxide with only tiny amounts of oxygen, which means there's no breathable air for humans. The average surface temperature hovers around negative 60 degrees Celsius, and it can plunge as low as negative 125 degrees Celsius in winter at the poles. Because Mars has only about 38% of Earth's gravity, long term effects on the human body, like muscle and bone loss, are still unknown. Finally, Mars lacks a strong magnetic field and a thick atmosphere, leaving the surface exposed to high levels of solar and cosmic radiation that could harm astronauts.
Even if we bring spacesuit or air tanks, long-term survival is extremely challenging.
And that's just for a basic survival because we also need food, water, and energy. We can't bring all of it from Earth. The weight would be too much.
So, what would a Mars colony look like?
To overcome Mars' harsh condition, scientists imagine humans living in carefully designed habitat. Underground shelter could protect astronauts from dangerous cosmic and solar radiation, while greenhouses would allow them to grow food in controlled environment. For energy, colonies might rely on solar panels or compact nuclear reactor to provide reliable power even during dust storm or long night on Mars.
We would need water too. Luckily, there's ice at the poles of Mars, but extracting it must be tricky.
And for the most important thing, the oxygen, you can make it from carbon dioxide in the air using machines called electrolyzers. But we'll need a lot of them.
Space is not like Earth. Even small problem become life-threatening. For example, microgravity makes muscle and bones weak. Astronauts in space need to exercise 2 to 3 hours a day to stay strong. Also, radiation can damage DNA and increase cancer risk. Psychological stress from isolation is huge. Imagine being a tiny habitat with the same people for months.
So, training astronauts is not just physical, they also need mental training.
Yes. Considering the vast distance from Earth to Mars, an average of about 225 million kilometers, any mission to the red planet is expected to take many months, making long duration space travel, life support, and psychological challenges key concerns for astronauts. It's definitely going to take a toll on their mental health.
Even with the careful planning and preparation, why it still take them a long time to send human there?
Even though we have rockets, traveling to Mars takes months, around 6 to 9 months, depending on planetary alignment.
Yes, that's a long time to live in a spaceship with limited space, limited water, and artificial air. Plus, resupply from Earth is hard. You can't just pop over to the store. Every item must be planned months of years in advance.
And that's why mission to Mars are slower than movies make them look. Hollywood makes it seem easy, but reality is brutal.
So, what is the next for humans in space?
Definitely, space exploration isn't just science fiction anymore. It's unfolding step by step. NASA's Artemis program is working to put humans back on the moon, setting up bases there as a first move. After that, Mars missions will likely start with them, small groups of scientists testing the waters. Then there's asteroid mining, where we could extract metals and also even water from the space rocks. And of course, space tourism is already happening. Tough, though, right now it's monthly a handful of wealthy people flying in just above Earth to the moon. Over time, it grew, and but probably it's in a slow phase.
The next decade also will be critical for space exploration. How we explore safely, responsibly, and sustainably will determine if humans can survive beyond Earth. With advance in artificial intelligence, scientists are exploring how AI can help on Mars missions, guiding robots and supporting astronauts, where Earth-based control is very limited. NASA's Perseverance rover has already completed AI planned drives on Mars, showing the potential of intelligent system in space.
But some people say that space exploration is too expensive. We have problems on Earth like poverty, climate change, and also hunger.
That's true. I won't deny it. But space exploration drives technology. Many inventions from space help Earth, like solar power, better insulation, and water recycling, and also robotics.
About this thing, it's not just about money, it's about survival. If humanity ever face a global disaster, having a population on Mars or the moon could save us, could save our species.
So, space is both a safety net and a tech booster. So interesting. Okay, now we leave space and zoom into something even smaller. Our very own bodies, biotechnology is about using science to understand life and sometimes change it. It sounds complicated, but it's basically humans figuring out how cells, DNA, and even protein works, and then using that knowledge to make medicine, food, and even organs.
So, we are talking about technology that change life safely.
Exactly. But safely is the tricky part. Small mistakes in biology can have really big consequences.
And the tools we have now are way more powerful than just mixing chemicals. The crazy part is we can actually edit genes.
Okay, now have you heard about CRISPR?
CRISPR? I think I have seen it in science article, but what is it really?
Okay, a report from Stanford University. CRISPR is a genome editing tool that allows scientists to change DNA in a precise and controlled way. DNA contains the genetic instructions for how living organisms grow and function. With CRISPR, researchers can cut DNA at a specific location and remove, add, or even replace certain genetic material.
So what you mean is, basically, if a gene is broken, CRISPR can fix it, right?
Yeah, or at least that's the goal.
Wow, that's insane. Can we actually rewrite life instruction?
Yes, but it's very precise. A tiny mistake can cause a lot of problems. Something like this involves with human life. That's why ethical rules are super important.
So, what can we do with the scripts are that you do in today's life?
CRISPR has the potential to do some pretty incredible things in medicine. Imagine being able to fix genetic disease like sickle cell anemia or boost the immune system so it can fight cancer more effectively. On top of that, doctors could develop personalized treatments based on a person's DNA, tailoring medicine to each individual instead of using a one size fits all approach. It's a huge leap forward in healthcare. And while it's still developing, the possibilities are exciting to think about.
You said before about tailoring medicine to each individual. So, what you mean? Instead of giving the same medicine to everyone, doctors can give the exact medicine to that work best for you.
Exactly. That's what we call precision medicine.
Um, and CRISPR isn't the only tool. Scientists are also growing organs in labs.
Yes. Imagine someone needs a kidney. Instead of waiting for a donor, scientists can grow a kidney in a lab from their own cells. That means less chance of rejection, right?
Whoa, that really can save 1,000 or million of lives. Nine.
And it's not just organs. Lab grown meat is becoming real too. Scientists grow meat in bioreactors from animal cells, so we don't need huge farms.
Lab grown meat also helps the environment, like less deforestation, less water use, and fewer greenhouse gases.
That's a double win. Humans and the planet.
Okay, but here's is the tricky part about all of this tech ethics. Just because we can change life doesn't mean we should in every case.
Hmm, like what?
Okay, for example, designer babies using gene editing to make kids taller, smarter, or with blue eyes is then technically possible in the future, but Is it fair?
Yeah. It could create inequality. Only rich people could afford it. Then biology itself become unfair, right?
Exactly. That's why most scientists focus on healing, not enhancing. Fixing disease is okay. Changing traits for preference is where ethics gets complicated.
Biotech isn't just about the DNA. It's pushing into all kinds of futuristic ideas. Think about smart pills that can deliver medicine exactly where it's needed instead of flooding your whole system, or wearable devices that keep track of your health in real time, giving you updates before you even notice something's wrong. And then there are tiny robots designed to move inside the body and actually fix the problems from the inside. It sounds like science fiction, but these are the real directions biotech is heading toward, and they could completely change how we think about healthcare.
Definitely. Like sci-fi, but it's real, right?
Yeah, but not through nanorobot has yet been tested in humans for clinical treatment. If it does, in theory, it can remove blood, clothes, or deliver drugs directly to tumors.
This leads us to a broader discussion about the future of medicine and how far can modern medicine advance in the future.
Then let's just ask ourselves, how far is too far with biotech?
Some say humans should never alter DNA beyond healing.
And others say if we can prevent suffering, we have a moral duty to.
But also, there is a risk. Small mistake in genes can be inherited by future generation.
I will say it's a balance between potential benefits and risks.
And society must decide, not just scientists. Laws, ethics boards, and public opinion all matter.
From all the things you said, biotechnology is powerful. It can heal, extend life, and even help the planet.
And in my opinion, it comes with responsibility. Mistakes aren't just accidents, they can affect generations.
Okay, the future of medicine is not just about science. It's about making smart choices ethically and carefully. That was my personal thinking.
So far, we have talked about AI, space, and biotech. Lastly, we will talk about energy and climate.
Okay, basically, energy is the foundation of everything we do. Without it, no lights, no computers, no rockets, and no biotech.
And how we get that energy matters a lot. Burning fossil fuels like coal, oil, and gas gives us energy, but also pollutes the air and heats the planet.
So, science is trying to find energy that is clean, safe, and almost unlimited.
Yes, let's talk about the renewable energy. The most obvious sources of renewable energy are solar and wind. Solar panels capture sunlight and turn it into electricity. Meanwhile, wind turbines harness the power of moving air to generate electricity. They are straightforward, clean, and already widely used, making them the go-to examples when people talk about shifting toward greener energy.
The technology is improving fast. Solar panels are cheaper and more efficient than they were 10 years ago. Wind turbines are taller and capture more wind.
But there's a problem of this renewable energy. For solar, sometimes the sun doesn't shine. Maybe because of bad weather, especially in tropical lands like Malaysia. And also sometimes maybe the wind doesn't blow. And that means electricity production can be inconsistent.
Yes, exactly, Shazwan. That's why energy storage is important. Batteries store energy when production is high, and in the same case, releases it when the production is low.
Modern batteries, especially lithium-ion ones, are getting better every year. They are not just powering phones and laptops anymore. They're storing energy for homes, cars, and even entire cities. That makes renewable energy like solar and wind much more reliable, because the extra power can be saved and used when the sun is not shining or the wind is not blowing. It's one of the key pieces that makes a clean energy future actually possible.
Researchers are also working on new kinds of battery that could take energy storage to the next level. For example, they are working on solid state battery. A solid state battery is use a solid electrolyte instead of the liquid electrolyte found in conventional lithium ion batteries, which solid state battery will make it safer, more energy dense, and potentially longer lasting. This solid electrolyte can be ceramic, glass-like, or polymer based, and it helps eliminate leakage and reduce fire risk common in liquid system.
So what you mean is better batteries mean we can rely more on renewable energy and use less fossil fuel.
Yes, definitely. And also, scientists are also researching on another potential energy source, like nuclear power. There are two types of nuclear power, fission and fusion. Tell me more about it.
Okay, so basically, fission is what we use in most nuclear plants now. A nuclear fission power plant generates electricity by harnessing the energy released in nuclear fission reactions. In a reactor core, heavy atomic nuclear, usually uranium 235 or plutonium, are stuck by neutrons, causing them to split into smaller nuclei. This fission process releases a large amount of heat and additional neutrons, which then sustain a controlled chain reaction. The heat produced is used to boil water, producing steam that spins turbines connected to generators, thus creating electricity.
Meanwhile, fusion is not like fission. Fusion is what powers the sun. It combines atoms and instead of splitting them. Nuclear fusion is the process of combining light atomic and nuclei like isotopes of hydrogen, deuterium, and tritium to form a heavier nucleus, releasing enormous amount of energy. This is the same process that powers the sun and also the other stars.
And the biggest challenges are that scientists must heat hydrogen into a plasma, reaching temperatures of around 100 million degrees Celsius, which is hotter than the center of the sun. The heat from this process is then used to boil water, producing steam that turns turbines to generate electricity.
It sounds very advanced, but in the end, isn't it still just about boiling water? What makes the difference than power plants like coal or gas?
Yes, the turbine steam setup looks similar, but the physics behind the heat source makes nuclear plants, especially fusion, cleaner, more energy dense, and potentially safer than fossil fuel plants. Boiling water is the end step, but the journey there is fundamentally different.
So, if we can make fusion work on Earth, it could give us almost unlimited energy with very little waste, right?
So the problem is it's really, really hard. Containing plasma at millions of degrees Celsius is not that easy.
Yes, Adib, but we cannot also forget scientists are making progress. Fusion could change the world. Clean, powerful energy for everyone.
Okay, all of this matters because energy choices directly affect to the planet. When we burn fossil fuels, they release carbon dioxide into the atmosphere. That carbon dioxide traps heat, which leads to global warming and drives climate change. So the push for cleaner energy is not just about technology, it's about protecting the environment and shaping a healthier future for everyone.
Yes, climate change has some serious consequences that we are already starting to see. Rising sea levels threaten coastal cities. Extreme weather events are becoming more frequent and intense, and many regions face drought while others deal with floods. It's a mix of challenge that shows how deeply our planet is being affected, and why tackling climate change isn't just about the environment. It's about protecting communities and everyday life.
So based on what you're saying, energy technology isn't just about powering cities. It's about protecting life on Earth too.
So, energy and climate technology are crucial. Without them, AI, space, and biotech wouldn't even work sustainably.
We have tools to reduce pollution, produce clean energy, and also protect the planet.
But tools are useless without responsibility. Humans must plan carefully and act ethically.